Hello, my name is Michelle and I am one of the teaching staff for Comp 6080. And today I will be giving a lecture on working with SVGs. So what is an SVG? SVG stands for Scalable Vector Graphics. It is essentially a type of graphic format, just like JPEG and PNG, but it has certain properties which makes it particularly useful when dealing with graphics for web development. And you've actually already been exposed to SVGs. So in the first assignment, you were given some icons which you had to render in one of the tasks. And these icons were given to you as SVG files. You will come across them pretty commonly as a front-end engineer. So what we're going to do today is we're going to try and understand a little bit more about how SVGs work. And we're also going to be building a few by hand. So before we deep dive into SVGs, we need to first distinguish between different types of media. When we're dealing with media, we generally have raster and graphic media. So raster graphics are things like PNG or JPEG. These are images which are made up of pixels on a grid. Each pixel has a certain color, and when the pixels come together, they form the image. Importantly, rasters have a resolution, which is the number of pixels that they contain. And that means that they have a finite number of pixels, which means that you will always lose some sort of quality when you enlarge a raster graphic. So as you can see on the screen, the pug, it's nice and crisp in its original form, but when you zoom into its eye, it becomes a lot blurrier and it loses a lot of the quality that it had previously. On the other hand, on the other side of the screen, we have a vector pug. And vector graphics are graphics that don't contain any pixels. They actually use mattes to display their images. And because they use mattes, they're not reliant on pixels, we can enlarge them pretty much infinitely without losing quality. So you can see when we zoom into the eye of the vector pug, it's still just as crisp as it is zoomed out. So some common file types for raster graphics, we've got PNG, JPEG, or GIFs. But for vector graphics, we've got PDFs, AI, which stands for Adobe Illustrator, if anyone is familiar with that graphic design software. And of course, we've got SVGs. So what is in an SVG, or what is an SVG made up of? We just need, before we do that, we do need to kind of refresh ourselves a bit with geometry and maths, because the way that we define SVGs is really by geometry. So just a reminder, a vector in geometry is something that has magnitude and direction. So when we're dealing with SVGs, we are essentially working with a coordinate system. And the coordinate system that we deal with is a top left system, which means that the origin is the top left corner. And all coordinates are expressed as x, y in terms of this top left system. So we generally will also give our SVGs certain dimensions. So we can see the element here has width and a height of 100, which means that this SVG on screen would be 100 by 100 pixels. So the next thing that an SVG has is a view box. We can think of a view box as kind of the visible region of the SVG. If the contents of the SVG was some sort of scenery, then the view box is the window through which we see that scenery. And so what that means is a view box is bounded. And we can see how we define this view box here is we've got two coordinates, 0, 0, which is the origin. We've got a width of 100, and we've also got a height of 100. And we can see that that's that box there. And anything that would be rendered, or anything that would occur outside of this view box, is actually clipped from view. Importantly, the coordinates here and the units here are not the same as the units that we use to define the SVG element itself. We can kind of think of these coordinates as internal to the SVG, whereas these are external. Even though they kind of look the same at the moment, later we'll see how they can differ. So just remember, these are often pixel units, but these are kind of their own internal sort of units. The next thing that SVGs have, which is essentially what's at the heart of the SVG is the contents of the SVG itself. So an SVG is made up of paths and vector shapes. And these are essentially, the things that make up the SVG and the things that we see. So what we can see here, what I've kind of tried to illustrate is this smiley face is actually composed of a few different elements. So we've got this large circle at the back, and then we've kind of got this like ellipse here. We've got like another ellipse here, and then we've got some sort of shape, which could be defined by some sort of path here. So that's essentially the contents of an SVG. What we're going to do now is we're going to look at different types of SVG shapes. So we have some built-in SVG shapes. And if you are wondering why I changed earphones, it's because my previous ones ran out of battery. So back to SVG shapes. The first one that we're going to be looking at is a line. A line consists of two endpoints, and each endpoint has an X and a Y coordinate. So we can see here that a line takes in the parameters x1, y1, and x2, y2, which correspond to its endpoints. It also takes in a stroke color. We do need to specify a stroke color with a line, otherwise it won't be visible on the screen. If I jump into my demo code now, you can see that I've got an SVG. It's got a view box with origin 0, 0 and dimensions 100 by 100. And the SVG itself has dimensions 300 by 300. And this is what I was referring to in that the dimensions of the SVG don't necessarily need to match that of the view box. The view box is just used internally so that the shapes and the paths know how to rearrange themselves. And they just get scaled according to whatever the SVG's dimensions are. So anyways, back to constructing a line. Because I'm essentially just working on a scale of 0 to 100 here, I'm just going to define my line to go from point 20, 20 to point 80, 80. So I just need to define my X and Y coordinates of each point. 20, 20 to 80, 80. And my stroke color will be some sort of gray. And that's essentially what it's done is it's gone from the point 20, 20 and it's constructed a straight line down to the point 80, 80. So that's a line. The next shape is a circle. So a circle consists of a center point and a radius. An additional styling feature of circles, because they are a closed shape as opposed to a line, which is open, we also have a fill color. So a fill refers to the colored in section, and the stroke refers to the color of the outer outline. So I'm going to use this same boilerplate code to define my circle. And I'm going to change my line into a circle. I'm going to center my circle at 50, 50. So I just need to define my coordinates, CX and CY. And I just need to define my radius, which in this case is going to be 40. So I've got my circle here. If I want to fill it in, I can also define a fill color. And I'm going to use some sort of yellow here. Cool. So yeah, it's centered at 50, 50 in this view box of 100 by 100, and it's got a radius of 40. So the next shape is an ellipse. An ellipse is very similar to a circle, except instead of having one radius measurement, it has two. It has one for the x-axis and one for the y-axis, but the center point is the same. So if I go back to my demo code, and I just change this into an ellipse. I want to keep the same center point. Let's make 40 the y radius, and I will make my x radius something like 20. And that's going to produce a squished up version of the circle, essentially. we've got the radius of 40, which is consistent with the circle, but the X radius is now significantly reduced to 20. The final SVG shape is a rectangle. It's a little bit more complicated, but nothing unsurprising. A rectangle basically takes in an X and a Y coordinate, which is the origin, and a width and a height dimension here, which basically defines how wide and how deep we want our rectangle to be. We can also define the roundness of the corners of the rectangle if we would like, by specifying, again, some sort of X and Y radius value. So popping back into my demo code, I can construct a rectangle. Let's give it an X and a Y coordinate of, let's say, 20, 30. We'll give it a width of 60, and we'll give it a height of 40. And you can see that this point here corresponds to the 20, 30. This point here corresponds to whatever 20 plus 60 is, so an X value of 80 and a Y value of 30 plus 40, so a Y value of 70. The fill and the stroke are the same as the previous two. We can also construct a rectangle with rounded corners. With the same dimensions, but let's set a value of 5. We can specify different values of the X and the Y radius, or we can just specify one, and that will cover both. Cool, so we can see we've got the same rectangle, but now with rounded corners. So those are all the basic shapes that we're going to cover today. The next thing that we're going to look at is something called the path. SVG paths is really where the power of SVGs comes through. When we were dealing with the built-in shapes before, we were kind of limited in the sorts of things that we could produce. We can still produce a whole bunch of different graphics just with shapes alone, but a rectangle had to produce a rectangle, a circle had to produce a circle. We would have to combine them creatively to come up with some sort of large image. With paths, we can really define any sort of generic shape with a path, because a path is really just a free form drawing. The way that you can kind of think of a path is it's a set of commands which you could give to someone if they had a pencil and a piece of paper. And if you gave them this path, they would know exactly what the drawing should look like, because the commands would specify where exactly, which coordinates they need to draw at, what the curvature of the drawing needs to look like. All of these can be described by a path. So we can see an example of a path on the screen. It kind of looks like a whole bunch of letters and numbers, but there is some sort of logic to the path here. The letters actually correspond to different command types, and the numbers correspond to different parameters which we give to the commands. So this is the full list of SVG path commands. We're not going to go through all of these. I've mostly just put it in here for like completeness and reference sake. But the main ones that we can go through, M stands for move to, and that is a command that says wherever we are in the path currently, I now want you to jump to this other location. L stands for line to, and that's saying wherever we are in the current path, I want you to draw a straight line to this other location. So it's not exactly like, it's kind of like move to, but it means that we're drawing a line as we move in that direction. H and V respectively stand for horizontal line to and vertical line to. They're pretty much the same as line to, but they're more specific in that we want to specifically draw a horizontal line to another point, or we want to draw a vertical line to another point. And then we have a whole bunch of curves, and we have an arc. Arcs are particularly useful for drawing different sort of curved figures. And finally, we've got Z, which is a special sort of command which signifies we want to close a path. So if we've drawn a path and, wherever the path has taken us, if we use the Z command, that's saying I want to now draw a straight line straight from where I am currently at in my path all the way back to the beginning of the path. These are the parameters that a path can take in. I'd recommend you have a look at the documentation online for more information on how exactly you use each of these parameters. But just going through some of the main ones, with the move to command, we specify the X and the Y coordinates that we want to go to. So this would say if X was 50 and Y was 50, we're going to jump from wherever we are on the path to the point 50, 50. And we're going to resume the path from that point. The same thing for L. It's saying we want to jump to this point 50, 50, and we're going to draw a straight line whilst we make our way there. Same thing for H and V. We're specifying the X and the Y coordinate that we want to jump to. With paths and with path commands, we can either specify them in terms of absolute coordinates, as we've seen here, or we can specify them in terms of relative coordinates. And the difference is that we use a capital letter for absolute commands and we use a lowercase letter for relative commands. Relative commands means that we specify values relative to our current position. So whereas previously, if we specified a capital M with 50, 50, that means no matter where we are going to arrive at the point 50, 50. If we use a lowercase m with 50, 50, that means that wherever we are, we're going to go to the point that's 50 units in the X direction and 50 units in the Y direction. So if we were previously at point 100, 100, we would now be at point 150, 150. Similarly for L, H, and V, they are all defined. They could all be defined in terms of relative commands. So here is a simple example of a path. I've got it written in terms of the absolute commands and the relative commands, but we'll go through the absolute one first. So the path begins at point 0, 0, and we know that because we've specified we want to move to the point 0, 0. From the point 0, 0, which is this point here, we then want to draw a line to the point 100, 100, which is this point down here. And because we're using the capital L, we know that we are specifically going to the point 100, 100. And because it is the command L, we are going to be drawing a line from 0, 0 to this new point. We then draw a line from where we currently are at 100, 100 to the point 0, 100. And it just so happens that it is horizontally to the left of where we are. And finally, we close the path with the Z command. And that means that we go from the point 0, 100 and we go back to where we started at 0, 0, and we draw a line in the meantime. Now we can write this path in terms of relative commands as well, as we've got down here. We need to start at the point 0, 0 so that we don't change. But instead of drawing a line to the point 100, 100 directly, what we can do is we can specify that we now want to move in the direction of 100 units in the x-axis and 100 units in the y-axis. It kind of looks the same here, but that's because we just started at the point 0, 0. But this is saying we want to move relative to the current point, not to these absolute coordinates. The path kind of differs in this next command. Whereas before we specified we want to go to the point 0, 100, now we're saying we want to create a line and moving in the direction of negative 100 in the x-axis and 0 in the y-axis. So what that's saying is if we were currently at the point 100, 100, which we are, we now want to be moving negative 100, so in this direction. So our new x coordinate is going to be 0, and we don't want to move at all in the y-axis. So our y coordinate stays the same as 100. So what we've done is we moved 100 units in the negative direction in the x-axis, and we have not moved in the y-axis at all. And then we close the path, and that's just the same as before. We just draw a straight line back to where we started. So that's a really simple example of an SVG path and how we can write it in both absolute and relative commands. Okay, so we're going to bring it all together now. We're going to draw this smiley face emoji using a combination of shapes and paths. So jumping back into my demo code, I've got an empty SVG here for my emoji. What I'm going to do is I'm going to start with the emoji head, so the yellow circle, essentially. I want my circle to be centered in the view box, and because my view box has dimensions 100 by 100 and is centered at the origin 0, 0, my circle is essentially going to have the center of 50, 50. So I just need to construct my circle with its coordinates, and I'm going to give it a radius of 50 so that it extends all the way to the edges of the box. And also fill it in. Cool, so we have a circle now, which basically goes all the way to the edges of the box, and it doesn't have any stroke because I did not define any stroke color. We now need to go in and fill in the actual features of the emoji. So we can see that the emoji is kind of, it has eyes that are kind of elliptical in nature. So I'm going to use an ellipse to create the eyes here. Again, an ellipse is defined by center coordinates. So my center coordinates here, if we're talking about the left eye, is going to be 35, 40. I am going to give it an X radius of 5 and a Y radius of 7. And that way it's just going to be a bit skinnier in the X axis. And we fill it in with the darker color. And voila, we have one eye. The other eye is identical, so we can use the same ellipse. We just need to adjust the X coordinates so that it's a little bit more to the right. So if I change that to be, let's say 30 units to the right, so it's now 65, I have a second eye. Awesome. The final part is the mouth. It's going to be a little bit more complicated because it's not one of the built-in shapes. So it's not an ellipse, it's not a circle, it's not a rectangle. We're going to have to use a path here. And the way that I'm going to construct this path is I'm going to start with this left coordinate here. I'm going to draw a line over to the right coordinate, and then I'm going to draw an arc which joins back up to my left corner. Now with arc commands, they have a lot of parameters. But the ones that we're really only concerned with are the first two and the last two. The first two define the X and the Y radius, so that's similar to how the ellipse radius was defined. The last two define the endpoint of the arc. So if you think of an arc, it has a starting point and it has an endpoint, and that's connected by some sort of curve. And we're concerned with where do we end, basically, and what does that curve look like. The middle coordinates, for anyone who's interested, this one controls how much the arc should be rotated by. And the two flags here, so the arc, the large arc and the sweep flag, basically they collectively control in which direction the arc should be headed in. So should it be headed in the clockwise direction or the anti-clockwise direction? But like I said, we're really only concerned with the first two and the last two right now. Cool. So I go back in and I construct my path. We need to start at the left corner. So that left corner is going to have coordinates 25, 60. I'm going to draw my line as a relative line, and that way I can just define I want a line that goes 50 units across to the right, and I don't want the line to move at all in the X direction, in the Y direction, sorry. So that's my line, which will take me over to the right corner of the mouth. And now for the arc, Again, I'm going to use a relative coordinate here, and I am going to define my X radius to be 10, my Y radius to be 8. Again, we're not too concerned with what the inner numbers are, so just bear with me as I just input those numbers in. But what we are concerned with is where we end the arc. So we want to end back where we started, which if we're currently at the right corner, where we started is going to be 50 units across to the left and no units in the Y direction. So we're going to go, oops, negative 50 in the X direction, and we're not going to move it all in the Y direction. And then finally, we're going to close it off with Z. Cool, so we have our complete emoji. We can also alter the emoji slightly so that it's no longer the happy emoji. If I just copy and paste the emoji, just with a slight alteration of the path, we can end up with a completely different face. Everything else can stay the same, but we just want to change the path so that, like I said, the middle coordinates control whether we're going in the clockwise or the anti-clockwise direction. If I just flip the flag so that we're no longer going in the clockwise direction, but instead we're going from here in the anti-clockwise direction, then we end up with a sad face. And we will also need to adjust the height of that starting point to something more like 75. Cool. Notice that I really only needed to adjust 1 point for it to move in the Y direction, and that's because all the other commands that I used were relative. So by adjusting where I start off, because everything else is defined relatively, I didn't need to go and make any additional changes there. Cool. So essentially what we've done is we've constructed a whole bunch of shapes. We've also constructed these two emojis using a combination of shapes and paths. That's pretty much all that we've got for today's lecture. I hope it gave you a little bit of a flavor as to how powerful and useful SVGs can be. And yeah, happy designing. Thank you for joining me today.